Hello everyone. Our project is called Infinitinote. We are two developers and software security engineers. Hafiz Rosari as a lead developer, myself, Parham Sadrizadeh as a software and security engineer, and Hiramani as a developer, who started this project as we saw the need to have a blockchain and decentralized solution for creating, editing, and sharing notes and documents. Existing solutions and centralized are like Evernote or Notion as an example. And who are we targeting? We are targeting individuals and companies who need to create and share notes and documents for different purposes, either personal or work. What are the problems are we solving? We created a blockchain version of existing solutions and also added more features like adding voice to documents. So what is the problem? Pain point for the users as a key reason for favoring more blockchain and decentralized solutions over centralized one is to increase resilience and reduce single point of failure. Decentralized system spread authority and responsibility across a network, which can reduce censorship and control, enhance security, prevent monopolies, and improve redundancy. So how big is the potential opportunity according to us? If blockchain solution can compete with Evernote and Notion with better features and subscription prices and have potential 200 plus million users. And at the end of the video, we will have the demo. And what did we choose to build on IC? Internet computing provides a decentralized infrastructure that aims to reinvent the internet as a computer that runs on the native protocol rather than relying on traditional server farms and cloud services. By doing so, it offers tamper-proof systems, open services, seamless integration, and reduced infrastructure costs. Infinity technical walkthrough will be Infinitinote is built using the internet computing ROS CDK for building the canister smart contract as well as Vue.js for the front end. The package DALI was used to implement generative AI, the data structures which are used by Infinitinote such as notebook, notes, and assets are represented as structs in Rust. Each notebook, notes, and asset has a global UUID, which is generated by calling the RARAN function on the management canister and then computing a SHA-256 hash to generate the global ID for the project, for the object. A principal ID is associated with the B3 map comprised of UUID notebooks. Notebooks have nodes associated with them and are stored in a type vector node data structure as a part of notebook. Each node has a vector of assets, which stores the UUID of assets uploaded and stores with the node. For the node editor, we leverage the tip-tab editor, which is JavaScript editor that can be integrated with Vue.js. We have also implemented real-time collaborative editing capabilities through use of Hocus Pocus server, which creates a WebSocket connection and shared document state that can be updated. Due to the cost of update calls on IC, we elected to implement the shared editing capability with a secondary support server running Node.js. Once editing is complete, the node is then saved to the internet computing backend canister. Assets are stored in separate B3 map with the asset UUID as keys and asset object as the value. Each asset has an associate ID, file name, and array of bytes. Large assets are uploaded in the chunk by calling method upload by chunk, which append new data to the asset byte array. Searching for notes and notebooks by tag is implemented via simple search and computing similarity of the search terms with the tags stored in the vector string of tags associated with each notebook or node. For AI, we are currently using library DALI with the open source Llama 13 billion parameters model released by Facebook. The user can leverage the AI to generate content, or by using the prompt summary can get a summary of their node content. Other prompt can also incorporate the node content to generate responses. By using more powerful server hardware, we intend to run the much larger and more capable 65 billion parameters Llama model. This will produce much more results in generating content. Okay, in this part, we're gonna have a demo on the actual application. So we go on browser and go to the canister URL, and we're gonna log in with internet identity. So we're gonna choose our ID. And log into the application. You see the dashboards, all of the notebooks. We could create new one. We call it test ICP notebook. So we create that. We going there. Gonna add some titles. Taste title, descriptions. So we're gonna have tags here, and we can have like drop file, like PDF, TX files, and we're gonna use the Infinitinote AI. We're gonna ask a simple question, for example. So we're gonna have like an AI integration and getting like a response from the engine. So lastly, we're gonna see the code snippets of the applications. Here are the code snippets of the actual application. And yeah, thank you so much, guys, for watching this video, and have a good one.